Welcome to The Explainer. Today, we are diving deep into the science of fingerprints, from that invisible smudge at a crime scene all the way to the courtroom.
All right, let's jump right in. You've seen it a million times in movies, right? The detective, the flashlight, that telltale smudge. But what is the real story behind that single crucial piece of evidence?
In this explainer, we're going to follow the trail of that invisible clue, and we'll uncover the science that turns a simple, accidental touch into some of the most powerful evidence there is.
To really get how this all works, we need to start with two core ideas, two fundamental principles that make fingerprint analysis even possible.
So the first big one is uniqueness, and this is the idea that no two people on the entire planet, not even identical twins, have the same fingerprints. It all comes down to this kind of chaotic, random process in the womb, a mix of your genes, your position, even what your mom was eating. It all ensures your prints are one of a kind.
And the second principle? Persistence. Basically, the fingerprints you're born with, they're the same ones you'll have your entire life. They form way down in a deep layer of your skin, so unless you have a really serious injury, they are your permanent biological signature.
Now, these ideas aren't some newfangled thing. People have been studying these patterns for centuries, starting with some of the first detailed drawings back in the 1600s. Eventually, Sir Francis Galton really nailed down those two ideas of uniqueness and persistence, paving the way for a system that could finally replace older, much less reliable methods.
But the real game changer, the moment that cemented fingerprints as the gold standard, came from this incredible case. See, before fingerprints, people used a system called Bertillonage, which was all about body measurements. But then, at Leavenworth Prison, two inmates named Will and William West showed up. They had almost the exact same name and measurements. The system completely failed. Their fingerprints, though, totally different, and that proved, once and for all, which method was king.
Okay, so we've established they're unique and they're permanent. But what about at a crime scene? How do you even find the ones you can't see?
Right. These are what we call latent prints, and they're basically just sweat and oil from your fingertips. Seriously, just think about it. Your finger is like a perfect little rubber stamp, and that sweat is the invisible ink, leaving a perfect impression on just about anything you touch.
So that classic dusting for prints you always see, it's a really careful four-step dance. First, an investigator shines a flashlight at a really low angle. That helps cast shadows to spot where a print might be. Then, they gently brush on a superfine powder that sticks to the print's oils, making it visible. They snap a photo right then and there, and finally, they use special tape to lift the print off the surface and stick it on a card.
But here's the thing, dusting doesn't work on every surface. For the tricky stuff, like paper or porous materials, the evidence goes to the lab. And this is where things get really cool. They can use techniques like cyanoacrylate fuming. Yeah, literally superglue, which reacts with the print and makes it visible. Then they can add fluorescent dyes that make it glow under special lights. Amazing!
All right, so we've got our print. It's been lifted, it's visible. Now for the million-dollar question. How does an examiner know for sure that it's a match?
Well, they don't just glance at it. They break it down into 3 levels of detail. Level 1 is the big picture. You can see it on your own finger right now. Is it a loop, a whirl, or an arch? Then they zoom in for level 2. This is the nitty-gritty, the specific points where individual ridges end or split. And finally, level 3 is like going under a microscope. They're looking at the tiny shapes of the ridge edges and even the location of individual sweat pores.
And to make sure this whole process is super objective and not just guesswork, they follow this strict scientific method called ACV. First, they analyze the crime scene print all by itself. Then, they compare it side by side with a known print. After that, they evaluate and come to one of 3 conclusions. It's a match, it's not a match, or it's inconclusive. And the last step, verification, is absolutely crucial. Another qualified expert does the whole process all over again, from scratch, to confirm the results.
Okay, so with a system this detailed, with all these checks and balances, it's gotta be perfect, right? The science is flawless? Well, not so fast. The answer is it's complicated. Because the final call isn't made by some supercomputer. It's made by a person, a highly trained expert for sure, but still a human. And all human brains have this little quirk called cognitive bias, our tendency to see patterns we expect to see.
And this isn't just a theory. A really famous and, frankly, tragic case from the 2004 Madrid train bombings showed just how real this risk is. An incorrect identification was made, and it was like a perfect storm of factors. The database kicked out a print that was unusually similar to the real one, and the intense pressure of a huge case probably led to confirmation bias.
But that huge mistake actually ended up making the whole field stronger. It was a massive wake-up call. It pushed agencies to adopt much stricter rules, like blind verification, where that second examiner has no clue what the first one decided. It just reinforced how important detailed notes and constant training really are to keep the process as objective as possible.
So, what's the big takeaway here? It's that the science of fingerprints is this fascinating dance between hard science and human interpretation. The patterns themselves, they're solid biological truth, but figuring out what they mean, that's on us. And it's a powerful reminder that even our best forensic tools are only as good as the careful, critical minds that use them.